Hey guys, here we are once again with another limit example. So this is going to be example number 3, and I already have our problem set up on the board. So let's just get right into it. All right, so this time again we have a piecewise function. We are looking at the limit as x approaches -3 of, and we have a 2 function, piecewise function here. So when x is less than or equal to -3, we are using this part of the function, 2x plus 5. And when x is greater than -3, we are using this part of the function, x minus 7. All right, so again, from the beginning here, I'm going to tell you that all of this, just to shorthand it, is f of x. So again, I'm going to do it from a tabular perspective. So I'm going to draw a table of values, and we're going to approach -3 from both sides. Okay, so I'm going to start by approaching, and remember the notation from last example, I'm going to approach -3 from the left. So numbers less than -3. So keep that in mind. So that means we are going to be what? -3.1, -3.01, because we want to be less than -3. We're coming from the left. So if you want to get a visual on it, if you have a harder time with negative numbers, you can always draw a little number line to help guide you. Okay, I'm coming from this side. So yeah, it should be -3.1 and on and on. When we come from the right hand side, we're going to be doing -2.9 and the like. All right, so we're going to go ahead and plug these in. So I'm going to start with -3.1. So -3.1 and then times 2 plus 5. All right, now I'm punching it into my calculator so we can get a value. So we get -1.2. Okay, and then again, we're going to step in closer to that. So -3.01 times 2 plus 5. You get -1.02. And we're going to keep going. And we keep getting till, again, we're confident in seeing the pattern. As a rule of thumb, I would recommend doing at least 4 values. It doesn't matter what 4 you want to put down. If you want to just jump immediately to like the 3.0001, but do at least 4 numbers, because we're going to see in some problems that, especially functions that might oscillate. So you might need a few more numbers just to verify the pattern. So don't just be okay with plugging in a single value and determining it from there. All right, I would in the beginning do at least 4. So now I got 3.001. So -0.001 times 2 plus 5. And we got -1.002. So I'm going one more time, really just to hammer it home, but you can already kind of see, I see a pattern with the numbers. And if I did plug in that last one, I really would get that picture. So as I approach -3 from the left, my function is approaching, and it looks like it's approaching -1. Okay. Now again, I'm emphasizing it because with the limit, we don't plug in the numbers. So could I have plugged in -3? Sure, because the function does take in, it allows as part of its condition that you can plug in -3. But we are approaching -3. We should never be plugging in that number. Okay, so now let's come from the right hand side. So I'm gonna do that down here. So now we're coming from the other side. So now that's going to be like our 2.9, -2.99, and so forth. So I'm just going to set that up already here. So we'll start with -2.9, and then we're going to subtract 7. So -2.9 minus the 7, so that's going to give me a negative 9.9. Then plugging in negative 2.99 would give me a negative 9.99. Plugging this in, and again, we're using this part of the function because we are greater than negative 3. We would have gotten negative 9.999. So when I look at my values, what does my function seem to be approaching? We now seem to be approaching is negative 10. So as I approach negative 3 from the right-hand side, it seems to me that I am approaching negative 10. Okay, so now when I look at this, when I come from one side, I am not in agreement with what's happening on the other side. So what does that mean? That means that the limit does not exist. So as I write my final answer, so in answering this original question that we were doing, the limit as x approaches negative 3 of this function, I say DNE, which stands for does not exist. And that will happen, okay? There's going to be times where, yes, the limit will not exist. So we need to verify that both sides are agreeing to the same value. When it does not occur, then we would say that the limit does not exist. So when we say does not exist, that does not mean that it's undefined. Does not exist means does not exist. Okay? If it's approaching infinity, then it's approaching infinity. Infinity is not the same as does not exist. So keep that also in your notes, that this is separate. This does not mean undefined. Okay? So I'm going to set up one more example in our next video, and I'll see you on that one.